Alright, so this is a library of functions. This is all kinds of different functions. When you see something like an x squared in an equation, if you see an x squared in an equation, you should kind of already know from Algebra 2, fingers crossed, what shape that graph would make. I think I heard somebody say something. A parabola, that's not a shape. That's the name of it, but like, you are correct, it is a parabola. What shape? Like a U shape, right. Or what about an absolute value? Here it is. How about an absolute value? A V shape? Yeah. So you kind of should know these things a little bit already. I'm looking for lead. That's what I'm trying to do right now. I'm like out of lead in everything. Oh. How's it going? Okay. When we see f parenthesis x, like right here, when we see that, we read that as f of x, and we're talking about the value of the function when you plug in an x. And because we're talking about plugging in and we're talking about what you get for the value, we're talking about domain and range of a function as well. So the domain of the function, we usually would use the x for that. That's our input. That's, when we graph it, that's the horizontal. Left to right. And then the range of the function, that would be our f of x, or our y values if we're using y. That would be our output. That would be the vertical, up and down. We just did 2 days of linear functions. So if we have a linear function, we have f of x equals mx plus b, what would our domain be? What numbers are we allowed to plug in for x? For a line. If you're making a table. Say it a little bit louder. All real numbers. So we can either write the words all real numbers. Oh my gosh, my hand hurts. Or you can use the symbol correctly, which is an R, but it has like a fancy double staff. Or so either of those would be fine for all real numbers. I'm going to use the symbol because it's available. How about the range? When I put in x's, is there any y's that I would not get out? For example, different function. If I put in an x into an x squared function, if I put the number -2 in here and I square it, what happens to -2 when we square it? It becomes positive. Like we would never get negative numbers out of here. If I put in an x into a linear function, am I ever not getting something out, or will I get all real numbers for lines? Like they go from all the way down to all the way up. Lines go from all the way down to all the way up. So linear functions, all real numbers would be the range. Intercepts, we would have one y-intercept, and we would have one y-intercept for sure. Maybe one x-intercept. And then behavior of the graph, that would be as x increases, y either increases or decreases. And what's going to determine if the y values increase or the y values decrease? Positive or negative. So I guess I could say or is constant. They call that they don't really call that linear. They call it constant because the x is gone at that point. Some books will put that with linear as well. There's just one line that is not a linear function. There is one line that is not a linear function. Does anybody know what line is not a linear function? The vertical one. And do you know why that's not a linear function? Because what's undefined? Right, but that's not necessarily what's making it not a linear function. Y vertical is not a linear function. Do you remember what makes something a function? The x value cannot repeat, right? When we look at all those ordered pairs, the x value cannot repeat. Or if you have a vertical line, it can't hit that vertical line more than once. But what happens if I have a vertical line and I've got all these x values, what's happening with those x values? They're all the same, yeah. I was going to try to make something up here. X, 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 and then the y's could be like 4, 3, 2, right? They're all the same. So that is not a function. It's not so much that it's not a line, it's just not a function. Okay. And we're talking about functions. There are two special types of linear functions. The constant function, that's like y equals 0x plus a constant, or y equals c. And the identity function is y equals x. So that's like right in the middle. Okay, I know people have missed this question on the quiz in the past. When we have a quiz, people have missed this question. You don't need to miss this question. It's easy. It's just like fancier because of the f. So here I'm giving you a linear function for f. So this is a linear function for which f of 1 is equal to 3. That means the input is 1 and the output becomes 3. Here the input is 4, the output is 0. We're going to write that equation, we're going to graph it, we're going to say the domain and range. So I'm going to start with the graphing. I don't know, visuals sometimes helpful for a lot of people. I'm going to start with the graphing. How do I graph f of 1, 3? Liam? Is that your name? Yeah, Liam? The ordered pair, input, output, 1, 3. Yeah. 1, 3. Because, you want to say because? Right, because the input is the x. Yes. And then that means the other f of 4 is 0. That's an ordered pair of 4, 0. And then we could take our straight edge. Ooh, I collected those. I'll have to give you guys those back. But guess what? Your planner, or your student ID, or your license, or your credit card, whatever. Anything's going to make a straight edge. So. Or it's notes. So if it's not perfectly straight, it's just notes. Okay, now we have to actually find the equation. So what would I need to find this equation? What kind of information? Jalen? Slope. All right, let's find the slope. 0 minus 3 over 4 minus 1. Give 3 over 3, negative 1. I got the slope. What should we do now? Madison, do you know? Point slope formula. So if you don't know the point slope formula yet, it is y minus y1 equals m times x minus x1. So y minus, which ordered pair should I use? Why? Because you want to use the first one? Why? Because it has 0. I lean towards the easier one, and I think the one with the 0 is the one I would lean towards, but it does not matter. So y minus 0 equals negative 1 times x minus 4. Y equals negative x plus 4. Oops, that's not the answer. Ooh, I was just about to do why everybody misses 1 point on the quiz. About to do that. Okay. This is a linear function that we're writing, and it gives me f of and f of, so I'm not going to put y equals for my answer. What am I going to write? F of x equals negative x plus 4. I almost did it, then I caught myself. And then we need to write the domain and the range of the function. So how far left to right does it go? That's the domain. How far left to right? Forever, all real numbers, so domain. Some of you probably learned a different way of writing the domain and range using infinities and stuff. We will do that. We're not doing that today. We're going to practice writing it with symbols and with greater than or less than signs. And then we're going to do interval notation in a couple days. So we're going to practice both ways. This is the way you're going to do it today. Range, how far up and down does it go? All real numbers. Okay, so what we're going to talk about is just all these different parent functions. The first one is absolute value. We know that that should look like a V shape. If you're not sure, value, V. When you do a table, it's really important that you pick values that are easy to take the absolute value of. So I left this blank here, thinking that you could think for yourself, what could I take the absolute value of? Do I want to only take the absolute value of positive numbers? Is that going to help me with my graph? I probably want to throw some negatives in there, don't I? What about 0? Should I throw 0 in there? It's a good, nice number to put in there, too. You want to make sure you cover everything that could possibly be on the graph. What do you think? There's like 5 spots. What numbers would be good to put in there? Negative 2, negative 1, 0, 1, 2. So that's probably the numbers we're going to use a lot, but not always. So if I put in negative 2 into the absolute value, it becomes positive 2. Becomes positive 1. 0 is 0. What does positive 1 become? Still positive 1. And then 2. Absolute value is how far a number is located from 0 on the number line. It's a distance, so it's always going to be positive. So now we're going to graph that. Negative 2, 2. Negative 1, 1, 0, 0, 1, 1, 2, 2. Are those the only points on the graph? No, those are the points I chose. So now we need our straight edge to continue that pattern so I get all the points on the graph. I have straight edges. Anybody want one? Way over there. Somebody want a straight edge? Do you want a straight edge? There you go. Okay, domain, range, intercepts. You know what? We're not going to do the behavior of the graph. We're just not going to take the time to do that. Domain, if we're looking at the graph, domain, how far to the left, how far to the right does it go? All real numbers. Range, how far down does it go? And how far up does it go? To infinity, right? So you're going to say y is greater than or equal to 0, or you could say f of x is greater than or equal to 0. Either would be fine. It's a function, so maybe f of x is better. I don't know. I think either is fine. Intercepts. Do we have any intercepts at all? 0, 0. Alright, next. That's the parent function for absolute values. Quadratic function. So this time we're going to square numbers. We're going to take x and we're going to square it. What numbers might be good to throw in that table? Small numbers? Okay. Like 0.2s? Not that small. No, I don't want to do those. I want to do integers, right? I get to pick whatever I want. I'm going to tell you, I usually use -3 to +3 because it fits on the graph really nicely. I didn't leave you enough space, but that's okay. You can just do 1, 2, 3. You can just extend it. And then I've done this so many times, and if you had me last year, you did this so many times that like those numbers should just like boom come out of your fingers because we did it so many times, right? And then when we graph them, right in the middle is our vertex 0, 0. Then we've got out 1, up 1, out 2, up 4. If you go out 3, you go up 9 in both directions. This is, somebody said parabola earlier, it's a parabola, it's U-shape. Of course, we stopped drawing all the lines now that I have it. You'll need something. And I just like having that third one on there because it really helps people who are not good at drawing parabolas just draw a better one. That's why I like having that third one in there. So domain, how far to the left, how far to the right? All real numbers. You're allowed to square any number. However, when you do square them, what happens? We don't have any negatives. We don't have any negatives. From range, low to high, the lowest number is going to be what? 0. Y is greater than or equal to 0, or you could write f of x greater than or equal to 0. And intercepts, 0, 0. Our next one is cubic function. So what numbers do we want to use for cubing? Small? What numbers do you usually use? You had your hand up, right? Why? Give me some numbers to use. I'll cube whatever number you want me to cube. Huh? 3? What if I cube 3? What number is that? Yeah, I don't want to do cube. Yeah, -2 to +2. I think those are good. So that's all you have to do is just think for yourself. If I cube 3, oh, that's not going to be on my graph. I'm not going to cube 3. All right? So go ahead and cube those. And when I cube a negative number, negative times negative times negative, it's still negative. This one doesn't have a vertex at 0, 0. It has something called a point of inflection, which we'll talk about later. You don't have to remember it right now, but that's a point of inflection. You could write it down if you're interested. Point of inflection. Domain, how far to the left, how far to the right? What am I allowed to cube? Anything, all real numbers. How far down, how far up? All real numbers. Intercepts, 0, 0. We're skipping behavior. Oh, I did that wrong. Now that I'm looking back at it. I was at 3 instead of -2. There we go. Okay, square root function. Square root. So we're going to make a table. But we're going to be smart about our table. What are we going to put in the table that we can take the square root of? Can we take the square root of negative numbers? Don't have to put any in those in my table. Can I take the square root of 0? You can. So I'm going to put 0 as the first x, and the square root of 0 is 0. What's the next one that I can take the square root of and would want to? Ooh, before that. 1. You can do square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. Should I do another one? Why should I not do 16? Oh yeah, it's not going to fit on my graph. Now I could rescale it, but we'll just go with those. Alright, so we're going to graph that 0, 0, 1, 1, 4, 2, 9, 3. And we have our square root function, which you guys should have done all of these last year. Domain. How far to the left does it go? 0, and then it goes all the way to the right. So we're going to say x is greater than or equal to 0. Range. How far down does it go? So y is greater than or equal to 0, or f of x greater than or equal to 0. Do we have intercepts? We do at 0, 0. I'm not going to do the behavior. The next one I called reciprocal function. You may have seen them as like rational functions, which has the word ratio in it because it's a fraction. We're not going to do a ton of this yet. We're just going to do a little bit of it and then do more of it towards the end of the year. What numbers would I want to put in, because I'm going to have to do 1 over that number? What would be good numbers to put in? Is it Neil? Okay, Neil. 1 and negative 1? Okay. Where do I want to put those? I'll just put them off to the side. 1, negative 1, because then I'll put them in order once we kind of come up with the idea of what. And I already said it to you, Liam. 0. Do I want to put 0 in there? We can put 0 in, but like he said, that's going to be undefined. We don't really want to use 0. What other numbers could we use? Could we use 2? Oh no, it gives us a fraction, but it's only a half. That's okay. I'm going to start with negative 2. I'm going to end with positive 2, but I think it's going to be a 6th one. I'm going to put negative 1 and positive 1 in there. There's one more I want to put in there. And I'm putting these in order, if it gives you a hint. A half. Why would I want to put half in there? Because it'll flip it and it'll give us 2. This is the reciprocal function. 1 over the number means it reciprocates it. So if I put in a half, it becomes 2. So negative a half, no, negative 2, negative a half, negative 1, negative 1. Now, as you're graphing this, are you remembering from Algebra 2 graphing anything that kind of looks like this? We had, when we did it in Algebra 2, we had asymptotes, and one of those asymptotes was at 0, because it would give you undefined. One of those asymptotes was there where x equals 0, and so the graph will never pass through x equals 0. And then also there is absolutely no way of plugging in an x and getting out a 0 for y. There's no way that 0 can be in the output. Bless you. And because of that, we have an asymptote at y equals 0, at x equals 0 and at y equals 0. Both of them have an asymptote. And then this graph gets closer and closer and closer to the asymptotes. Has 2 little branches. So we're going to talk about the domain. How far to the left, how far to the right does it go? Got arrows. How far to the left, how far to the right does it go? It's all real numbers except 0 cannot be, because we can't use 0 to be undefined. So we're just going to say x does not equal 0. That's going to just mean it's everything except for x does not equal 0. How about the range? How far down does it go? How far up does it go? What? It's everything except for 0, right? It goes all the way down, it goes all the way up, but not equal 0, and that's the y value, so y does not equal 0. Intercepts. There is none, right? Okay, so now we are going to take these parent functions and move them. How many people last year did transformations? Yes. So if you did not do transformations, you can just plug in any x's you want and find the y's by plugging, that x into the equation and adding 2. I'm going to do these using transformations because I feel like you should have done them last year. But you can do your table however you want. I'm going to choose my table by transformations. So what do I do if I'm doing transformations? I'm going to first use just x squared by itself. I'm going to use x squared to start. So I'm going to plug in whatever x's I want, -3, -2, -1, 0, 1, 2, because those 3, because those are the ones that I square. I'm going to square them real fast. 9, 4, 1, 0, 1, 4, 9. So that's just a squared. And then there's this +2. After I square it, now I add 2. So I'm going to add 2 onto all the squares. 11, 6, 3, 2, 3, 6, 11. So I did plugging in an x, squaring it, adding 2. That's what I just did. I just kind of did it in 2 columns rather than doing it all in my head. So the ordered pairs that I would graph would be -3, 11, which kind of doesn't fit on the graph, almost though, close enough. -2, 6. -1, 3. 0, 2. 1, 3. 2, 6. 3, 11. So I took that parabola parent function and I added 2, which bumped it up 2 spots. What is the domain? How far to the left, how far to the right? So all real numbers. The range, how far down? +2 and then all the way up forever and ever. So we'll say that f of x is greater than or equal to 2. Or y is greater than or equal to 2. Alright, so I don't know if I was making it clear. You can either use this transformation table like you probably did in Algebra 2. Who came from honors? Do you guys do tables like this in honors, or do you use like plug numbers in? Okay, I can't hear anybody's answer. Just plug numbers in?
Yeah.
Did you like say, well, this is our parabola here, and we just need to move everything up too? Okay, so that's fine too. Different teachers do it different ways, so. All right, so next one. We're going to look at this, and you're going to determine what's the parent function. Cubic. So I'm going to do this using a transformation table. You can do it however you learned it is fine. Since it's cubic, I'm going to choose numbers that are easy to cube. -2, -1, 0, 1, 2. If I don't have those memorized, then I just use my brain and say, what numbers can I cube easily? Then I will cube them. -8, -1, 0, 1, 8. So that's just the cubic parent function. Once I do the x cubed, if I were plugging in any number, if you're just picking a number and you're plugging it in, let's say I'm plugging in -2, what's the very next thing after I cube it that I would do? -2 cubed is -8. What's the next thing I would do? Like order of operations, if I did this, 1 minus -2 cubed. So far we've done this. What's the next thing that you would do? Corey? I would totally do that next. I would change the sign next. So that's what we're going to do to all of these, is we're going to multiply them all by negative 1. 8, 1, 0, negative 1, negative 8. And when we actually do a page of transformations, I'll talk to you more about what that means for the graph. But today we're just graphing it. Transformations are coming up. Okay, so after I multiplied everything by negative 1, that's you changing this into positive, then what would we do? We would add the 1 to the 8. So that's what we're going to do. We're going to add 1. 9, 2, 1, 0, negative 7. What we graphed is our x and our latest y. We're going to graph negative 2, 9. Negative 1, 2. 0, 1. 1, 0, 2, negative 7. What if I graph it and it does not look like a cubic shape? If it's a cube in the question and I graph it and it does not look like that cubic shape, what should that do to me right away? Yeah, it should be telling me, you're wrong! Go check your work. Right. Almost done? 2 more. So we have oh wait, did I do my domain and range? Oops. What's the domain and range for cubic? All real for both. There's no restrictions on cubic. As I look at square root and think about, there's restrictions on square root. So square root of x would be my parent function. So what numbers would I want to square root? 0, 1, 4, 9. Maybe 16, but we'll see. When I take the square root of those, 0, 1, 2, 3. So now we think about order of operations. Over here, let's say I plugged in 1. Let's say I was doing h of 1. Let's say I was plugging in 1. What's the first thing that I do over here? I add the 1 and the 4 and then I square root. That's not what I did over here. What? Say again. What? Prob, was that you? It was not him? You guys are laughing. Was it not him? Or is he lying to me? Okay. I'm trying to think about how do I describe this, but now I'm stuck in, do I describe it as transformations or not transformations? How about I do both? So you either plug in numbers and you square root. What happens if I try to square root 1 plus 4 like that? Yuck. Okay, so there's another way of doing it this way. If you do your transformation, I mean, you can do it that way. You just have to plug in x's that you can square root. Like, what would be a good x to plug in? 0. What would be another good x to plug in? Negative 3. So this is just making a table. You can plug in whatever x's you want. What would be another one to plug in? Negative 2. And then if you plug in 0, you would get square root of 4, which is 2. If you plug in, negative 2 is not a good idea. Why you shake your head yes? What's another good one to plug in? 5. It's going to give us 1. This one would give us 3. Okay, if you're using transformations, those of you that remember transformations, what would we have to do? Audrey? Yeah, for those, we'd have to subtract 4 from the x's. And that's kind of what you were doing when you were just picking numbers. You were saying, if I took away 4, 0 would be an easy one to do. So that's kind of what you were doing when just picking numbers for a table. I don't care what method you guys use, by the way. You can use either method, as long as it's not, well, I typed it in my calculator. You need to be able to do this stuff without a calculator. You can check it in your calculator. So if you subtract 4, we got negative 4, we'll get negative 3, we'll get 0, and we'll get 5, the numbers that you were coming up with anyway. So negative 4 is 0. -3, 1, 0, 2, and 5, 3. Domain, how far to the left does it go? -4, so it's going to be x is greater than or equal to -4. Range, how far down does it go? 0. So, again, I don't know if I'm making it clear, but I don't mind if you guys want to use transformations from last year or if you're just plugging things into a table. Both of those are good skills. The only thing that I'll say about plugging stuff into the table is sometimes you don't get the center of the figure and you have to find more points. All right, last one. Wait, when are we done? 55? We're good. Last one. P of x is, we've got absolute value, so I'm going to do absolute value of x minus 2 and then subtract 3. So you can either plug in any numbers you want into the table and graph it. I'm going to use transformations. That's the way I teach in Algebra 2. I think it's helpful because I'm going to get that middle of the V, that vertex of the V, where if you're just plugging in random numbers, you might just have like an end and you won't know where that V is until you keep plugging in more numbers. And I think it takes longer to do it that way. So if we're doing transformations, then I'm picking whatever x's I want that I could absolute value. -2, -1, 0, 1, 2. I'm going to take their absolute value. 2, 1, 0, 1, 2. And then if I have this -2 on the inside of the absolute value, is that going to affect my x values or my y values? Okay, I want people who are confident to yell it out because I could not understand that. If it's inside of the absolute value function, horizontal, so that's going to be x. Thank you, Pop. So on my x side, and remember, if you're remembering horizontal stuff, we always do the opposite operation. You're going to be adding 2. It's kind of like you're undoing what's being done to the x. You're undoing it. So it's going to give us 0, 1, 2, 3, 4. And then the -3 happens after we absolute value, so that's happening after the function. That's an outside, that's a vertical transformation. So that goes to the y value. Subtract 3. So 0, -1, -2, 2, -3. And if you do it using transformations, you will have the center of that V. If you don't do it using transformations, that's okay. I'm going to go over that more in depth in like next week, beginning of next week. Domain, how far to the left, how far to the right? Our real numbers. Range, how far down? -3. So we're going to go y is greater than or equal to -3, or you could write P of x is greater than or equal to -3. All right, assignment is a graphing assignment. Yay.